5 times across history, evolution has rewritten the sea's story, sculpting unrelated creatures into the unmistakable form of a crab. This is not an accident. It is a recurring blueprint chosen by nature for its brutal efficiency. But why does the ocean keep forcing life toward this shape? The answer hides inside the very machinery of survival, and it changes what we think we know about evolutionary limits. In 1916, a British zoologist named Lancelot Alexander Borradaile sat down to describe a pattern he could no longer ignore. As he studied crustaceans from around the world, he noticed a peculiar habit of nature. Different creatures with different histories kept arriving at the same unmistakable shape. Borradaile gave this strange phenomenon a name: carcinization. The word draws from the Greek word karkinos, meaning crab, but it stands for much more than a label. To Borradaile, carcinization meant the many attempts of nature to evolve a crab. It was a quiet challenge to the idea that evolution always travels in new directions. Instead, he saw nature looping back over and over toward the same solution. Borradaile's insight did not come from genetics or fossil records. Those tools would come much later. His evidence was the animals themselves, lined up in jars and sketches, each one a separate experiment in becoming crab-like. That term, coined over a century ago, turned a repeating curiosity into a puzzle with a name. With carcinization, Borradaile handed scientists a riddle. Why does the ocean keep sculpting the same form from such different clay? The question still stands. What is it about the crab shape that keeps luring evolution back, again and again? To answer, we have to look closer at what it really means to be a crab. A crab is more than a name. It's a blueprint stamped by 5 unmistakable features. The first is the carapace, a wide, flattened shell that shields the animal from above, spreading like a living shield across the back. This plate is not just armor. Its broad, low profile anchors the crab close to the ground, making it harder to overturn and easier to wedge into cracks or under rocks. Beneath the carapace, the abdomen, called the pleon, tells the second part of the story. Unlike the long, muscular tails of lobsters or shrimp, a crab's pleon is shortened, folded tightly under the body. This hidden tail tucks away vulnerable soft tissue, transforming what was once a swimming appendage into an internal support, out of reach from snapping jaws and claws. The third marker is the claws, formerly chelipeds. These aren't just for show. Each claw is a multi-tool, capable of crushing, slicing, digging, and even signaling to rivals or mates. Their size and strength can be startling, sometimes outgrowing the body itself. Next are the walking legs, arranged in a modular pattern. There are 4 pairs, jointed and splayed to the sides, which allow for that signature sideways scuttle. The limbs aren't just for movement, they are built to grip, climb, and even regenerate if lost. Finally, the entire body is compact and low-slung. Every part is drawn inward, armored, and close to the ground. This tight design is the crab's secret, making it a master of the seafloor, equally at home wedged in coral, burrowed in sand, or prowling tidal rocks. These 5 traits, together, define the crab form, a shape nature keeps returning to again and again. Inside every crab, the blueprint runs deeper than the shell. Carcinization does not just flatten the body or tuck the tail, it rewires the entire animal. Muscles that once powered a lobster's backward sprint shrink and fade, their job erased by the new design. The crab's folded abdomen, locked beneath the carapace, means the legendary caradoid escape, a lightning-fast tail flip through water, is gone for good. Instead, the crab bets everything on armor and ground tactics. The broad shell acts as a bunker. The compact build anchors it against the sea floor, and the legs splay wide for sudden sideways bursts. But this armor comes at a cost. The trade for stability and defense is the loss of speed and flexibility. No crab can rocket away like a shrimp. What they gain is a kind of staying power. Claws become tools for cracking, digging, and even communication. These claws can regenerate if lost, a rare trick in the animal world, offering a second chance after a fight or a brush with a predator. Inside, organs shift to fit the new shape. The heart, gut, and nerves rearrange around the folded tail, forming a tight, efficient package. Every part is pressed inward, protected, but also limited by the hard shell. Evolution rarely reverses this process. Decarcinization, the return to a long, flexible body, has happened only a handful of times. Once the blueprint locks in, nature rarely lets go. The crab form is not just a shape, it is a commitment, a one-way door that so many lineages have chosen and almost never abandon it. In 2021, a research team led by Heather D. Bracken-Grissom used genomic data to settle a question that had haunted naturalists for a century. By mapping DNA from hundreds of crustaceans, they confirmed what the jars and sketches had only hinted at. The crab form has evolved not once, but at least 5 times. Each event unfolded on a different branch of the crustacean tree, with no shared crab ancestor to explain the similarity. The true crabs, Brachyura, represent one lineage. King crabs, with their hulking frames and deep sea habits, belong to another. Porcelain crabs, delicate and flattened, are a third. Coconut crabs, armored giants of the land, make a fourth. The fifth, less famous but no less crab-like, is the squat lobster transformation. Genomic markers show these lineages converged on the crab blueprint independently, sometimes separated by over 100 million years. Fossils support the timeline, but it is the genes that reveal the pattern. 5 times, nature has written the code for a crab. Evolution, it seems, keeps returning to the same answer. Ancient stone and amber hold a silent record of nature's experiments. In the heart of the Cretaceous, nearly 100 million years ago, a small creature was trapped in tree resin on the edge of a vanished sea. Its name is Cretapsara athenata, a crab so perfectly preserved that even the hairs on its mouthparts remain, its gills still arched for water that vanished ages ago. This fossil, sealed in amber, is the oldest modern-looking crab ever found, and it appears as if it could scuttle away at any moment. Nearby in time, but stranger in form, Calichimaera perplexa swam through warm Cretaceous waters. Its wide eyes and paddle-like legs hint at a body plan unlike any living crab, yet the blueprint is unmistakable: a flattened shell, a tucked tail, a compact body, nature's familiar signature. These fossils are not isolated oddities. The Cretaceous crab revolution, spanning 95 to 100 million years ago, saw a burst of crab-like forms, each a separate answer to the same evolutionary question. Across continents and ancient seas, the record repeats, the crab shape rediscovered and reimagined, preserved in stone and amber. Even in deep time, the ocean kept making crabs. Nature has a habit of repeating itself. Across the vast sweep of evolutionary time, the same shapes and solutions keep reappearing, as if life is working from a favored set of instructions. The crab is only one example. Streamlined bodies emerge again and again in creatures built for speed: sharks, dolphins, and ichthyosaurs, separated by millions of years and entire branches of the tree of life, all shaped by the demand to slice through water. Wings, too, have sprouted on insects, birds, and bats, each time unlocking the sky with a different blueprint, but arriving at the same answer: flight. When faced with similar challenges, evolution draws from a limited toolkit. Physical laws and survival pressures act like boundaries, channeling life toward forms that work. The crab's compact, armored body is one of these recurring solutions, a shape that keeps winning the evolutionary lottery. Given enough time and enough chances, nature always circles back to its favorite blueprint. The unsettling truth is that the rules of life are not as open as they seem. Evolution favors what works, and crabs always return. Evolution doesn't play favorites. It plays what works. Today, the crab form thrives in every ocean, a testament to nature's relentless repetition. As our world changes, the blueprint persists. In the end, the ocean doesn't reinvent survival, it perfects it. What shape will nature choose next?